Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to go over section 3.2. Um, 3.2 will be split into two parts. There is going to be a lot of terminology in section 3.2, and there's going to be a lot of things that you feel like you're going to have to memorize. But later on in the section, everything's going to kind of come together for the following. So 3.2, we're going to talk about polynomial functions or polynomial graphs. Okay, so let's remember, what is a polynomial? So if we look at this, right, the idea is that it should be of the following, where it's where you just have a number multiplied by a variable to a high degree, and then as you go on, right, your degree goes down as you progress, and then at the end you'll have a number. Okay, so just remember some rules for a polynomial. A polynomial, right, should be adding and subtracting a bunch of terms, and also must be a positive exponent that is a whole number. Okay, and it cannot have a variable on the bottom. So this one here is not a polynomial. Why is that? Because I have an x on the bottom. This one here is not a polynomial because I do not have a whole number as an exponent. Okay, so you cannot have things. It cannot be negative, and it cannot be a fraction. Sorry, it cannot be kind of a fraction that is not a whole number. So these two don't work. This one, as you can see, does work. X cubed is 5 plus 5x. This one also works because if you notice, you don't have a variable on the bottom. You do have a 2, but that's okay. That's just 1/2. So that's for the following. So what happens when I graph polynomials? When I graph polynomials, it's always going to be what's called smooth and continuous. Okay, so what will happen if I graph non-polynomials? It's not going to be smooth and continuous. Okay, so what do we mean by smooth? Smooth means it's a graph that has no corners or cusps. Okay, so what do we mean by that? Okay, when we say something smooth, pretend it's almost like if you're looking at a graph, right, and you're like, say you're like driving on this graph, right? So the idea is when we mean smooth, we mean that there should be no jagged edges or no corners or cusps. Okay, so if you notice here, right, this graph here is not smooth because if you notice, if I kind of show where my arrows are, right, notice I'm making these kind of sharp turns. Pretend almost like you're driving on this. Pretend it's like a road, and you're making these like sharp turns as you go along. So it doesn't work. Also, this graph doesn't work because it is not continuous. Okay, a way you can help you understand for continuous is if you're drawing your sketch, you should not have to lift up your pencil. If you lift up your pencil, then it's automatically not continuous. So notice if I'm drawing here, and then once I hit the spot, right, I'm forced to lift up and then sketch this again. So that's why that is not continuous. So this one is not a polynomial graph. Okay. Now let's take a look at this one right here. Even though this one is continuous, we have what's called a cusp. Okay, so if you notice a cusp here, it's smooth, it's kind of curvy on one edge, but then all of a sudden it's kind of straight back up. But regardless, right, visually, right, I'm forced to, say if you're driving on here, you're forced to make a sharp turn right here. Okay, so this one doesn't work. And the last one does work because it's kind of a smoother transition and it's connected. So therefore, this one is a polynomial graph. Okay. So one thing too is if I graph the ones that we have up here that I X'd out, they will actually not be continuous, or they will have sharp turns in the graph. Okay, so let's talk about some more basics dealing with polynomials. Okay, so the first thing we want to talk about is what's called end behavior. Okay, so end behavior. So while you look at this packet here, and this is also in your PowerPoint and this is also in your book. They have a lot of standard definitions. They are a lot to take in, but I want you to kind of understand just the general basics. Try to also interpret this in your own words, but there is kind of a lot happening here. Okay, so when we talk about end behavior, we're talking about as we look towards the left and to the right. So a lot of times when we look at end behavior, right, we're looking at, let's say if I'm looking to the left or to the right of the graph, right, I'm determining whether if my graph is maybe increasing or decreasing. Is it going up? Is it going down? Or maybe it's converging or approaching a specific number. Okay, so when I have an even integer, right, that means, for example, if I have like an even integer, right, for example, if I have like x squared, x fourth, x sixth, okay? And then when we talk about power functions, we're talking about specifically a term with the highest degree, okay? So let me give you an example. If I have x to the 7th plus 5x6 minus 4x squared plus 3, right, this is a polynomial. My x to the 7th here is going to be my power function I'm going to be using. If I have negative x cubed plus 5x, my negative x cubed is what I'm looking at for my power function. Okay? So if my power function is even, it is going to look like this. Okay? Sorry, let me do that again. So the idea is my power function for an even is going to, at the very end, is going to look like this. They're either both going to go up or they're both going to go down. Okay? Now, we may not know what goes in the middle. Okay? So let me show this to you right here, right? So like if I graph like x squared, I can see that as I'm going towards the left and right, it's going up. And it's kind of going in a kind of parabolic, right? It's going to be a U shape towards the middle. But now if I have something like this, like x to the 4th plus 3x cubed minus x plus 7. Okay, I'm just kind of making this up. So notice, okay, my ends are still the same, right? It's still going left. Whoops, sorry. They're both going up, right, through the left and right. But notice in between, it's just kind of a weird shape, right? It kind of has this little odd curve. It's no longer a U. So that's the thing that we have to realize we can't take for granted. We will not understand what will happen in the center, but we do know from the left and right, it's either both going to go up or both going to go down. Okay? It will always go through these 3 points. Okay? For the following here. And then domain is a set of all real numbers. But I would say the most important thing is understand where they're kind of going. They're either both going up or they're both going down. Okay? Odd functions, it's going to look like this. They're either going to go, it's going to be opposite direction. So one's going to go to the left and one's going to go up as you're going to the right. It's going down when it's going left. Or it's going to be vice versa, like this. Now, just like even functions, we may not know what happens in the middle. Okay? Right? There might be some funny curve. It might just be one curve. It might be 7 curves. We don't know. We just care about what happens at the ends. Okay? And that will always hold the same for all odd integers, right? So such as like x to the 7th or x to the 5th. So end behavior is going to be the one so end behavior is going to be one characteristic that we focus on. The next type of thing that we want to focus on is x-intercepts and zeros of a polynomial. So let's take a look at this here. So let's take a look at the following. So when you have zeros, okay, what do we mean by zeros? Zeros is a fancy way of saying x-intercepts, okay? So we're trying to figure out when, so let's say I have a polynomial graph. I'm trying to figure out when it hits the x-axis, right? So notice it's here, 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 right? These are all of my zeros, right? So where my arrows are pointing at, where it hits the x-axis, is when my zeros are. I'm trying to find the specific x value such that it hits the x-axis. Okay? So let's talk about two specific situations, okay? Um, so the first situation is the concept of multiplicity. So multiplicity essentially means that you may have kind of duplicate answers, okay? So if I have, say, a multiplicity of 3, that means I have a number that is repeated 3 times, okay? Or an answer, or a 0 that's repeated 3 times, okay? This is going to make more sense later on. But more importantly, we want to talk about even and odd multiplicities. So what do I mean by that right there? Sorry, let me go back up. So if I have a even multiplicity, right, which means like I have an even multiplicity of 2 or 4 or 6 or 8, then it will touch the x-axis at r, okay? But if I have an odd multiplicity, it will cross, okay? So let's see if that, okay. So let me do this here. Okay, so if you look at this graph here, I actually have 2 odd multiplicities, okay, because they actually cross. You see, I know that it doesn't touch. But now if I graph something like this, let me graph another example. Let's say I have x squared, right? If I graph x squared here, notice my graph just touches and bounces, so therefore I'm going to have an even multiplicity. So an even multiplicity, again, is going to be something where it's going to just touch the x-axis and it's going to jump away. But then if it's odd, it's going to immediately cross through. Okay. In our second video, we're going to have a lot more situations like this for the following. Okay. So let's look at some examples here. So let me go down. Okay. So if I have a function like this, let's talk about what my zeros are. So these are in factored form. Now, if you recall, when we were like finding domains or when we were doing things, yeah, when we were doing like finding domains, we were like factoring them. We set all of them equal to 0. It's the same thing, right? So this is in factored form. So I'm solving each one of them by setting them each one to 0. So my zeros are the following. I have x is equal to 3. I have x is equal to 4, right? And I have x is equal to negative 6. Okay? So let's take a look at what my multiplicity is. So my multiplicity right here, if you take a look here, let me actually just make this a little bit larger. Okay, sorry about that. So my multiplicity here is going to be the following. It's going to be my exponents up here. So I would say x equals 3 with a multiplicity of 2. I'll do MULT for short. X equals 4 with a multiplicity of 5. And then x equals negative 6. This is the one that trips people up. It's multiplicity of 1. Because if you notice, I don't have an exponent. Remember, x to the first is just x. Okay? So, if you think about this, I really have 8 zeros. Okay, why is that? Because I have 3 and 3, right? 3 being repeated twice. 4, 4, 4, 4, 4, 4 being repeated 5 times, and a negative 6 being repeated once, right? So 2 plus 5 plus 1, I have 8 zeros, or I have 8 answers. I don't have 8 unique answers, I just have 8 answers. 5 of them are repeated, 2 of them are repeated, and then 1 of them is by itself. So what's my power function? My power function is really x to the 8th, okay? So that means, right, if I graph it at the very ends, they're both going to go up for the following. Okay? So let's look at another example here. Actually, I'm going to make this one like negative 3 x minus 7 x plus 3 square. Okay? So what are my zeros? I'm going to set x minus 7 equal to 0. I'm going to set x plus 3 equals 0. I have x is equal to 7, x equals to negative 3, right? These are my zeros right here. And what's the multiplicity of each one? This one is a multiplicity of 1. And then this one is a multiplicity of 2. Okay? Yeah, and I decided to put a negative because what will my power function be? My power function will be negative 3 x to the third because I have 2 plus 1 is 3. I don't need to worry about the 3 out in front, but the thing is I do need to focus on the negative. Okay, and then once again, I intended this to be negative. Okay, my apologies for that. But I do need to be worry about the negative because I know it's negative odd. So idea is if I graph it, I know it's going to look like this right here, right? It's going to start off high and it's going to end up being very low. Goes towards the bottom. Okay. So the second thing you want to focus on is what's called multiplicity, whether it's even or odd, and then when it crosses, which we'll get to in a bit, but then also what my power function is for the following. Okay. Now, in college algebra, you are going to be expected to know the following here, where you are doing things in reverse, right? So what we just did was they're like, oh, here's a polynomial. Find all these traits, right? Try to find your zeros, try to find your multiplicities, okay? So now notice something right here. This is where it kind of flips on you. So they're like, here's all your zeros. Here's your power function. It should be x to the cube. If I look at number 1, now make a polynomial. So you're going to go backwards. Now let's think about this, right? If we go backwards, right? Remember, when we have x equals 7, notice what is my factored form. My factored form is x minus 7. So your answers here are going to be opposite signs of what your factors are going to be. So since my 0 is negative 4, right, it'll become x plus 4. Since I have a 0 at 4, it flips to x minus 4. And this 2 flips it back to x minus 2. And I have f of x is equal to this. This is my polynomial. Now it should be 3 because notice if I have, this is a multiplicity of 1, 1, 1. So 1 plus 1 plus 1 is 3. Let's look at another example right here. Yeah, let's look at these two here. So I have zeros with 2 with a multiplicity of 2. So I have x is equal to 2. My factor form will be opposite. It will be x minus 2. Now they said to give us a multiplicity. So I'm going to put the 2 on top, x minus 2 squared. Next one says 5 with a multiplicity of 3. So this is x minus 5, and I'll raise it to the third power. And that'll be it. Let me rewrite that again. So I have f of x is equal to x minus 2 squared, and then x minus 5 cubed. And so if you notice, the multiplicity just ends up resulting in the exponent on top. Okay. And then your zeros are opposite signs. Notice that ends up being 5 because 3 plus 2, I'm adding my exponents. 3 plus 2 is 5. That ends up here. Okay, let's look at one last one. Negative 3 with a multiplicity of 2. So I change my signs. It'll become x plus 3. Remember, your 0 is opposite of your factor. Multiplicity is square. 4 with a multiplicity of 2. So it'll be x minus 4 square. And then 6 with a multiplicity of 1, that'll just be x minus 6. If I have a multiplicity of 1, it'll just be, yeah, I won't have to put an exponent on top. You can do x minus 6 to the 1, but it's just a little bit redundant. Okay, it's not wrong, but it's generally not necessary because remember, x to the first is just itself. Okay. Okay, so make sure you know how to go backwards and forwards. So sometimes they'll give you a polynomial to be like, what are your zeros? What are your multiplicity? And then sometimes they'll flip it around. They'll be like, here's your zeros, here's your multiplicity. Find your polynomial. Okay. So let's talk about the last type of characteristics with 3.2 that you want to know. You want to know what's called turning points. Okay? Turning points are points that change a graph from increasing to decreasing. Okay? So we're trying to figure out when it's going to go, when it changes from increasing to decreasing. Also, your turning points essentially are your maximums and your minimums, right? Your relative max and your relative mins, right? We've talked about that in the very first sections for chapter 2, right? Increasing, decreasing, relative max, relative mins, right? So essentially your turning points, right, are your peaks and valleys. That's another way to think about this. Okay? So the two rules is the following. If the polynomial has a function of degree n, then f has n minus 1 turning points at most, okay? If the graph has n minus 1 turning points, then you have a degree that's at least n. This can be a little bit confusing, okay? So, for example, let's say if I have a degree of 5, I will have at most 4 turning points. Now, it doesn't mean I only have 4 turning points, or I can only have 4 turning points. I could have 3, I could have 2, I could have 1, right? It just means I can't have the same amount of turning points as my degree n, okay? And then the vice versa is true, right? So if I have 4 turning points, I must have a degree 1 more than my turning points, okay? It doesn't have to be 5. It could be 6. It could be 7. It could be 8. It just has to be greater than the number of turning points in my graph. Okay. So now let's talk about the following here. So if I look at my graph at the top left, I have 2 turning points, right? I have one here and I have one here. So because I have 2 turning points, I'll just say 2 turn points for short, right? What will my function be? At minimum, it has to be x cubed, okay? And it could be, right, if I really want to, it could be x to the 5th, it could be x to the 7th. Okay, now notice some of you guys are like, well, why can't it be x to the 6th? That's greater than that's greater than 2 turning points. Yes, you're correct, but if you notice something, we can look at what's called my end behavior, right? So notice it's going up in the right and down in the left, and that is an odd, right? If it was x to the 6th, they either are both going up or they're both going down at the very ends, which is not true. Okay. Let's look at let's look at 2 more examples. So here, how many turning points? I have 1, 2, 3, 4, 5. I have 5 turning points. So my minimum has to be x to the 6, which makes sense because they're both going up towards the ends, right? My end behavior has them both going up. Okay? It's not just x to the 6, it could be x to the 8th, x to the 10th, x to the 12th. Okay. So, let's look at one more. Let's look at this green one here. Now let's look at this. How many turning points I have. And again, if you're thrown off by the turning points, think of it as a relative max. I have one hill. I have 2 hills and 2 valleys, so I have 4 turning points. So I have 4 turning points. Okay, so what is my minimum? It's going to be x to the 5th, which is my power. Now this is going to be tricky. So if you notice, it's going left from the, it's increasing from the left and decreasing from the right. So that actually means it's negative, okay, for the following. So that's it, okay. If you're not sure too, graph it, okay, and you can kind of see kind of the direction it's going for your end behavior. Okay, but let's talk about this. So polynomial graphs, we want to figure out whether something is polynomial or not, whether it's smooth or continuous. Okay, and then we want to look at specific characteristics. So what are the characteristics that we focus on? We focus on end behavior. We focus on the power function. We focus on the zeros, whether it's odd or even. So that means whether it crosses or touches. We want to look at multiplicity. And then finally, we want to focus on turning points. Okay. Now, everything I share with you may feel like it's just a bunch of random things that I discuss. Okay. Kind of hang tight. Okay, because once we hit to the next video, we're going to understand why all these things matter and how all of them kind of fit together. Okay, but other than that, I will see you guys later.